Hello everybody, it's my pleasure today to announce the formal launch of the XylyX project. And this is a continuation of the project that has been going on for about a year on my YouTube channel, the XylyX YouTube channel, which has been a collection of videos regarding general relativity and the attendant mathematics of differential geometry, to include topology, the study of manifolds, and the study of tensors. And the XylyX project is going to continue. We are going to keep going. There's a lot in this material to study. In fact, I'm sure that we could go on forever and ever and ever and branch out into newer and more fascinating things. And there's no reason not to just keep on going. So with the launch of the XylyX project, we are launching a Patreon page to help support this endeavor. The Patreon page, I've already got a logo set up. This is the landing logo. I like the mirror symmetry of XylyX in this logo over here. I also kind of like the feeling that it's got a bit of a waveformy shape going on. The connection coefficient is also part of our formal logo, and an alternative version of the XylyX icon as well. And we've created an icon to promote the project as we move forward. The Patreon page is accessible through patreon.com, and this is the patron name for the XylyX project. And as you can see, this is what the Patreon page will look like. It's got this logo that we just discussed earlier, and I focused on the XylyX is creating lectures about general relativity and related mathematics. There's a small introduction, and you're absolutely welcome to come here. And for those of you who have spent so much time with the XylyX project already, for those of you who have the means and are interested in supporting this, when we begin accepting patrons, all of the collected donations will go to supporting the XylyX project through new technology to assist us with either producing the videos, consuming a little bit of our energy of building a database for the community, and other things that have to do with production values. And you know that the production values that have been in the XylyX project have been a bit sketchy. They've been up and down. They're getting better, but there is a certain spontaneity about this that will not change. This is basically lectures on YouTube, and a lot of it is just the time and energy to keep it all going. Also, I would like to have some forums and circumstances where the participants in the XylyX project can interact directly with myself over some of these topics, and also select new topics. I'd like patrons to be able to select new topics. In regarding this, we have chosen several tiers of membership. But the key point for the tiers is I want to reward patrons with something that's tangible, something that's already been produced in the XylyX project. And what that will be are these two books that I have completed, and just working on some of the finishing touches completely appearance-wise. And the first book, which will be for those patrons who have cumulatively provided $10 of support. So that means if you support at the $2 a month level, in 5 months I'll send you a copy of this book. If you do $10 a month level, 1 month I'll send you a copy of this book. You get the XylyX project $10 one way or another through Patreon, you'll get a copy of this book. Patreon doesn't take one-time donations, but if you donate at the $10 a month level for 1 month and then stop, that would satisfy the patron requirements to get a copy of this book. And this book I had written couple years ago now, but because of the time and energy considerations, I haven't put the finishing touches on it until recently. But it's called Why Does It Move? Elliptic Integrals, Elliptic Functions, and the Geodesics of the Schwarzschild Spacetime. And this book covers several key topics. It's an intermediate general relativity book, but I go into some serious depth about a very specific topic: the geodesics of the Schwarzschild spacetime. And in doing this, you have to understand a mathematical concept of elliptic integrals and elliptic functions, which I do the mathematical physics of these two mathematical concepts. We dig into extremely deeply, And it's a wonderful introduction to elliptic integrals and elliptic functions, and you can kind of see some of the attendant mathematics here that I threw down on the cover. An example of the interior of this book is here. You see, for example, you see the connection coefficients are calculated for all the different connection coefficients for the Schwarzschild spacetime are calculated, and here you recall that this is the metric connections formula. So we run through the metric connection formula for every single metric coefficient. In other words, this is a lot more detailed in the analysis than you will find in almost any other general relativity book. There are some that do this kind of deep level, step-by-step breakdown of the entire process, but not many. And that's what I promise you in this book, is a very step-by-step, very detailed analysis of the entire construction of the Schwarzschild spacetime, and then the formulation of the geodesic equations, and then ultimately the calculation of the geodesic equations. I derive the geodesic equations in this book, what I call the hard way, which means I went into Meissner, Thorne, and Wheeler and went to his analysis or their analysis of the geodesic equation development, and I filled in every little gap I could find. And I created a lot of charts and pictures for this book. These are all original graphics done by the XylyX project, and they're all intended to really tease apart the meaning of these mathematical expressions to the extent that it's possible to do in a graphic form. This, for example, talks about the variation of a path, where if this is a path through space-time, you could vary that path by making it this red path. But another way to vary that same path in space-time is to reparameterize it. It's got the same path through space-time, but now it's reparameterized using a different parameter. And that counts as a variation. So we talk a little bit about that, and that element is very important in deriving the geodesic equations. And ultimately, when we do derive the geodesic equations, you know, if you followed along with the work on YouTube so far, I love to express things in different forms of notation, change notation, examine all the notations in unit systems. And here you see that I maintain that in this work. I've strived to have a very, very excellent LaTeX presentation. I've chosen to script the LaTeX very carefully, and I have the same mathematical concept expressed in multiple different ways from different sources. One of the core themes of this book is I take 3 papers that analyze the geodesics in the Schwarzschild spacetime, 3 separate analyses, and I blend them all together. I use a book and a paper by a man named Kostic. His paper is probably the most straightforward. And Chandra Sekhar's textbook, I throw that in there. And then there's a couple other papers as well. And I credit the authors. There's nothing original in this initial part of the book, at least. But I definitely am using multiple sources, and I'm blending all of their equations together. And to me, that helps me learn, is seeing the different approaches different authors take to the same subject, and I just throw it all together, and I try to keep everything very well organized. That's the goal of this book, at least. I produce, again, my own graphics, and you'll see I have some wonderful charts in there showing the different kinds of orbits you can get in a Schwarzschild spacetime. And what's interesting, of course, is in a Schwarzschild spacetime, if you pass by a neutron star, say represented by this little dot, or a black hole, you can get orbits that cross themselves. You can get orbits that are cloverleaf orbits, right? That shouldn't be a surprise, because we all know that orbits precess. But you can make this precession massive, not just tiny little Mercury-style precession, but huge precession. So each swing, you go to a different place in the orbit. You can have multiple circulations and then an escape in a Schwarzschild spacetime. There's just many, many different possibilities. And you can also have some circular ones. So we discuss how these are all calculated, and using the high level of symmetry of the Schwarzschild spacetime, it turns out that there are some classical physics references we can use, like this curve here, which should be familiar to those who've studied any orbital mechanics in the Newtonian system. But in order to calculate the paths of these orbits, in order to calculate those paths, you need to understand the elliptic integrals and elliptic functions. And so we spend a chapter or 2 going through just that, the mathematics of the elliptic integrals and elliptic functions. This is classical mathematics. It's beautiful mathematics. It's not easy, but we go through it in step-by-step detail, and we cover every bit about it. And from then, you can use that to calculate literally these orbits. These orbits were originally calculated from a paper by Caustic. I've independently duplicated those calculations in this book and matched them with Caustic's work to make sure that I got everything correctly. And you can see that the idea of these pictures, for example, is the coordinate time of a ticking clock that orbits a neutron star along this particular geodesic path. And if you're on that orbit, if you're free falling along that orbit, this is the clicks of your clock. And you can see that the clock of the proper time orbit is not ticking at the same rate as the coordinate time orbit, and that's very, very important. And calculating the gaps between these ticks is not at all easy, and it's almost this elaborate, beautiful, amazingly complex collection of expressions that involve these elliptic functions here. And we go through every one of those in deep, deep detail using several different methods. And then I produce a graphic showing the actual world line. Right? The neutron star in space-time is this big cylinder sort of gushing through time at the speed of light. And then the orbit sort of goes around that cylinder. And so this orbit here is very similar to this orbit here, but now I'm now expressing it with an additional time dimension. And we have several graphs and charts like that I think are very intuitive and instructional. And then there's a second book about a different subject. It's not actually about the general relativity, but for those patrons who get a total sum of $20 of total support, meaning either 1 month of $20 or 2 months of 10 or 5 months of 2, however you can get $20 to support the XylyX project through the Patreon system, you'll get a copy of Qualified to Complain. Qualified to Complain is sort of a title that's meant to sort of sarcastically go after students I've met who've told me things like, oh, the standard model is such a mess. And then I ask them a little bit about the standard model, and it's pretty evident that their understanding of the standard model is not very thorough. And they're not wrong. The standard model certainly, I think, is arguably a mess. But you're only qualified to say the standard model is a mess is if you really understand how it's built and what it is and why it's a mess, and pointing to very specific reasons why it's a mess. So the point of this book was to sort of vamp on that silly idea. I mean, I'm not complaining that people are concerned about the arbitrary appearance of the standard model, but I want them to know that arbitrary appearance. I want them to understand what that arbitrary appearance is. So we take the standard model, and we start from literally zero, and we build it from scratch. And I'll just show the contents here. But I start by creating 3 fermion fields. And these fermion fields, we talk about the gauge transformation of 3 fermion fields, and we call that the color transformation. And if our universe had only 3 fermion fields, we'd be done right about here. But then we talk about the gauge invariance, and this has a lot to do with the connection that we've studied in the theory of general relativity. And then we start adding particles one by one. I add leptons. We talk about the gauge invariance of leptons. We talk about the U1 gauge invariance, and then we combine these two to create gauge invariance of this group SU2 tensor product, or I'm sorry, SU2 and U1 gauge invariance. And then we create the Lagrangian of the universe up to that point, 3 fermion fields with a couple leptons. Then after we're done with that, we add the notion of chirality. How do we make this a chiral theory? And then in there we talk about weak neutral and weak charge turns. So we add everything in one by one, and then after we've added things in, we update the Lagrangian of the universe again. Then ultimately we say, hey, let's just throw in some new field, the Higgs field. We add in the Higgs field, we create a new broken Lagrangian, and we break it. I go through the entire process of the symmetry breaking of the Higgs bosons, breaking of the Lagrangian symmetry. And then we go on and we talk about how the fermions get mass from the Higgs bosons, or from the Higgs field. And then ultimately we create a final Lagrangian. And that final Lagrangian is this massively messy thing. And for example, that final Lagrangian here, this would be near the end of the book. You see each of the terms of the Lagrangian is specifically broken out. The quark kinetic term, the lepton kinetic term, the kinetic term of the Higgs boson, the mass terms for the W and Z particles, the mass terms for the Higgs coupling to the W particle, the Higgs coupling to the Z particle, which you'll notice is very different, and the Higgs self-coupling, the quark-gluon interaction, and then the charged-weak interaction. Each one of these things, each of these expressions in the text, we build it up very systematically. This is not an easy book, right? This, I do assume a certain amount of understanding of group theory. We do introduce ideas about SU3 and SU2, and we explain how those transformation representations work. But this isn't an introduction to the Standard Model. This is for a person who's floated around the Standard Model, never really caught it all together, and wants another swing at really assembling the whole idea. And that's what this book is for. And at the $20 level, I'll be happy to email it to you. So that's the basic idea, everyone. We are now launching the Patreon page. I'm really, really grateful for all of the support you've have been giving me over the past year. Your lovely comments on the YouTube channel, and the XylyX project will persist. And please visit the Patreon page. If you can support, go ahead. If you can't, please continue to watch the YouTube channel. I'm not going to monetize the YouTube channel. I don't think we have that level of attention to it. Not that I would. I do want to endeavor to make all of these things as low cost and free as I can, and your support will allow me to write additional books. We have books planned in the future for mathematical physics, a book planned in the future for a detailed description of the black hole universe, meaning traveling through Kerr black holes and other things of that nature. So thanks again, and we'll see you on the YouTube channel.